On this page, we are continuing what we were starting in the other video, which is showing how we would show the triangles congruent in order to say the statement that is above them and, explain our reasoning there. So it's going to be like sort of like the end of a proof that I'm going to do for each of these. In this picture, I noticed that they share a side and it's not currently marked. So I need to mark it, and then I need to say anything that I'm adding a marking to, like the marked stuff, I'm going to pretend that's given and I'm not going to write it down. Although if I was doing a proof, I would write that down. But anything we mark ourselves, I'm going to add in and I'm going to put the reason. So those are congruent by the reflexive property, the shared side. Now we can see that all the sides are marked. So I'm going to name the congruent triangles. I'm going to say STV. For the first one, that just seems like it's easy to replicate over here, would be UTV. And my reason would be side, side, side. And then I would be able to say that angle STV is congruent to angle UTV. And again, these are weird markings. They're supposed to be angle marking. By, my reason would be CPCTC. Corresponding parts of congruent triangles are congruent. So the beginning of the proof would be listing off my givens, which was these two sides that were marked, and then this is the end of the rest of the proof. Over here we've got two pieces marked that would be our givens. We see this bow tie looking picture again. We've got vertical angles going, so I'm going to mark those and I'm going to list those as though I was doing part of a proof here. I'm going to say angle EDF. And you have to name them with 3 letters because there's more than one angle there. Congruent to KDJ, because vertical angles congruent. And now I have enough to say that the triangles are congruent. I've got 2 sides and the angle in the middle, so it's side, angle, side for the reason. So I'm going to name the triangles. I'm going to say EDF. Congruent to, E started at the end of this one with 1, so I'm going to start at K, KDJ. And the reason is side, angle, side, because there's 2 sides and the angle in the middle. And then I'm able to say what they wanted, which was that EF is congruent to KJ. Those are 2 things that were not originally listed that they wanted us to get to. So we had to prove the triangle's congruent and then get there by using CPCTC. And then the third one here, this one has parallel markings. These are not congruent markings, these are parallel markings. So parallel markings, they always lead to congruent angles. So what I'm noticing is that I've got this Z shape sort of going. Those are my favorite pair, these alternate interior angles. I've got them there, and I've also got them going on the sides here, which would make them here and here as well. It gives me 2 sets of angles. And then these triangles, they share the side in the middle, so I'm going to mark that as being congruent. Parallel markings are not the same as congruent markings, so don't be thinking that the sides with the parallel markings are congruent unless they also have a straight line marking to show that. So I'm using the things that I added in here, and that will be angle, side, angle for the reason, because there's 2 sets of angles and the side that's in the middle. So I know that I'm going to use angle, side, angle. I'm just going to make myself a note up there. But I have to list off all the stuff that I just marked here. So I'm going to start by naming the angles. Angle YXZ is congruent to angle WZX. And I'm going to list both of these because the reason is the same. WXZ congruent to angle YZX. And the reason is alternate interior angles theorem tells me that the angles are congruent. Then I also want to say that they share that side, so that's XZ congruent to XZ. and the reflexive property. And then I'm able to say that the triangles are congruent. So let's name them. If I said WXZ, W had no markings, so I need to start at Y. I went from W to X, which had 2, so I need to go from Y to Z, which has 2, and then to X. So then that's angle, side, angle for the reason. And they had to be in matching order, so, be on the lookout for that. And then I'm able to finish it off with the last statement, XY congruent to ZW by CPCTC. So that's kind of a long one for a proof here, and then the only thing that would be before that would be the parallel lines that were given to us. So kind of like a proof, but not quite.